back with another episode of Object Stats. I'm flying solo today. Next time, I think we'll be back with either Kieran and me. But today, we're going to take a closer look at one of our newer products that we just released this year, the AI Multicam. And today, with me, I have Ben and Marshall. Ben Calderon, I've worked with for a very long time at this point. But maybe you could introduce yourself and talk a little bit about your role at Samsara.
Yeah, great. So CTO for hardware and operations. So yeah, we've built a lot of products together, right? And I think what's really fun about my role is really just to build these devices and work with this team on the hardware side that really is helping digitize that world of physical operations for our customers. And I always think of hardware as kind of that aspect of our company that gets it into the cloud and then also is upfront and integral with operators that interface with our technology as well. And so it's a place where we may be running AI detections or doing super simple sensor data gathering. But either way, I think it's kind of that key interface that many of our customers actually interact with Samsara. And then I'd like to introduce Marshall here. So Marshall is part of our product design team, so on the mechanical engineering side, and has been with us for over 2 years now, I believe, and was super integral in the mechanical design, system design, and validation, and even all that field testing for the AI Multicam. You want to introduce yourself?
Yeah. I'm Marshall Haltom, and like Ben said, I'm a mechanical engineer here. I came most recently from the autonomous vehicle industry, and it's been really exciting to work on a product where you can take it directly to the customer and it works today. And there's a lot of this bringing some of these AI functions that are very new and very exciting for customers, and being able to apply them on any vehicle that a customer might want. Right out of the box.
Well, awesome. Well, let's dive into it. Why don't you guys tell us a little bit about what the multicam is and how it's different from our existing product?
Yeah, great. No, I think the AI Multicam really builds on some of that dash cam technology we've built today. It's very similar, and it is able to do AI detections, we call it like at the edge, right, or in a vehicle. And I think there is some predecessor to this where for many years, if you had a large vehicle or a bus, maybe, especially in passenger transit, you might have a mobile network video recorder. They might have IP cameras in a vehicle, or they might have these AHD cameras as well. But I think there's just been this groundswell of desire to have Samsara integrate with these cameras that they've seen, and there's also just a need for more cameras, more visibility as they see the benefits of the dash cam. So I think what we've done here is really created a solution that pairs with our products, our VG and our dash cam, and creates a seamless experience where we can essentially add 4 more video feeds from what's going on and have detections run on those, similar to what we do in a dash cam. And just like, we could record the video, automatically send up events, and then have video stored on a device so that we can retrieve it should we ever need. I think this program really encapsulates what we've done to use the Samsara, tactic of bringing this advanced technology, making it easy to operate, easy to install, and delivering a tangible value to these operations and safety teams.
And you guys brought one of the demo kits here. Why don't we take a look and dive in, and we can show everybody exactly what the product is.
Yeah.
So this is our AI Multicam demo suitcase of sorts, and this is how we can kind of show the idea of the 360-degree visibility before you actually, install it on a vehicle. So, of course, you can see in the middle here the Multicam hub, the white box there, and then we have an array of different cameras looking around the sides of this case representing our vehicle. And what this can do, of course, you can see 4 camera feeds on the display. And then as soon as you hit, for instance, put the vehicle in reverse, you can highlight that camera and pick up things like pedestrians in this case, or other things that you might want to see around the vehicle and highlight those for the driver. So, you're not just looking at this tiny screen and trying to figure out what's going on there. make it a little bit easier on the driver. And as we were testing this thing, and I was driving our Freightliner step van around the streets of San Francisco, you do come to appreciate how useful it is to have cameras on every side of the thing.
Yeah.
I mean, you've seen a lot of deployments, so at this point, I know you've traveled quite a bit. I'm curious, like maybe some of the types of vehicles you've seen this on.
Yeah, I mean, we've installed these on all sorts of different vehicles, from construction equipments, loaders operating in very harsh environments, to garbage trucks, many of those, buses, both coach buses and school buses, all the way down to a transit just delivery van or a pickup truck. So our customers have used these just about everywhere, and in fact, another example, on ground service equipment at airports.
Oh, yeah.
So they're all over the place, and that's kind of part of the challenge of this thing. Is unlike a dash cam, for instance, where generally it's going to be in the windshield roughly just about every time, the environment can change quite a bit across the different use cases.
So maybe you can kind of outline it. Like if we take an example of like one of the garbage delivery trucks.
Mm-hmm.
So can you kind of point out exactly each component and where they would end up being in the cab? Because my understanding is like we have that guy, kind of the head unit, plugs in all the cameras, and then this unit is actually up in the cab so they can see around the visibility.
Yeah. So for instance, in a garbage truck, your driver might have the monitor, up and to their right, so they can see behind them, to either side of them, and even in the hopper of the garbage truck, so they can see if there's any contamination or anything like that. So some of these cameras, for instance, might be on the back of the truck, pointed out to the side. So as they back out of a alleyway and can't see, whether they're blocking traffic or what might be coming from the side up to them, they can see that before they get there, of course. So all around the vehicle, and we've seen actually the camera locations vary quite a bit too, from on the side mirror to the back of the truck facing the side. Backup cameras, of course, looking at the arm of the garbage truck to see and be able to prove to a customer that you actually emptied their trash. So they can really be all over the place.
And then how do you see the different views on the monitor? I saw you flipping through those.
Yeah, so there are a few different ways. We have the benefit of already being plugged into the diagnostic port on the vehicle, and that actually is a huge boon for installing things like this. So you don't necessarily need to go and figure out where the reverse light wire is and tee into that, or where the turn signals are. You can actually pick up those things on the diagnostics bus, especially in heavy duty vehicles. It can be that feeling of just plugging it in and then having the views magically start changing without needing to wire anything up, I think is pretty magic. It certainly was for me the first time I installed it, and it worked. And I think that's part of the benefit that we have with the ecosystem of products that we built.
That makes sense. So maybe you could talk about the cameras and like the interface to this, because this is looking back. If we rewind, I know like even when we kind of got started, we saw some of these more advanced applications and multicam things, and folks were actually almost taking traditional NVRs, like things that had been used, for video surveillance, if that makes sense, and just putting them in buses and stuff like that. That was probably like 5 or 10 years ago. This is just a very different, kind of solution. Maybe walk through some of what's changed in the camera technology and stuff like that, because I know those used to be it was like kind of massive overkill for mobile kind of deployments. And
you'd see mobile NVRs, right? And we still see them quite a bit. And so, and one of the beauties about this solution is you can just kind of swap that out, and that's what we're kind of doing. So we're modernizing, possibly an existing solution on a vehicle where they have some of these AHD cameras, and so they oftentimes have standard interfaces, but there's just a few wires that goes to each one of these cameras. And what you were seeing in this box here is that we have different like side cameras. We've got they could be mirror mount cameras, or on the fender. It could be also in the rear. They all have infrared, so they work well at night. But the solution was designed so that you can do both a greenfield deployment or have a retrofit case where you're pulling out one of these NVRs, and then so in our AI Multicam box there, now not only does the storage and gathering all these feeds. And then, but it also enables it to be uploaded to the cloud. Events can be detected, just like we do with our dash cam, so that we can have those automatic detections, those quick videos automatically sent, and just works just seamlessly, just like the dash cam system. So that's why in this demo kit here, we put it all together, so it can be demonstrated, on a desktop, on a conference room table, and so that's I think it's something that's pretty impressive to see just in one box, essentially.
Yeah, that's super cool. Really, really interesting. I'd be curious just to hear from you guys. I know, I spend most of my time on the software side, and it's almost like just a given that we'll iterate a lot, with our customers. And with software, it's a little bit easier because, I think especially in the last, decade or so of really understanding how cloud software works and seeing AI and knowing that, it'll get better and better. What is that process like on the hardware side?
Oh, that's a good question. I mean, the iterative approach works well for engineering, certainly for software. And it's a great way to kind of evolve and improve upon, your product. Now, we do employ that too in engineering and hardware engineering. However, there is this finality you get when you have to kind of generally release something, GA, and you go into mass production, and so what we try and do is we try and use that iterative approach, but we compress it to maybe it's like a 6, 12, or 18-month period, and we'll have several prototypes, several iterations on the system. And that includes the firmware that runs on a device, or the product design on all the mechanicals or the electricals as well. And we try and get these things to converge in a few different, we'll call them builds, where we go and have a dry run and dry rehearsal and put it all together, and then we go and we take these devices out and test them. And so, and then sometimes there could be some of these sub-tracks, like say on the product design. I think it was a big challenge on the ruggedization of this, Marshall, where, you did a lot of prototyping early on. And I think even if you encounter a challenge, we might have to go do some quick side prototyping, and then you go back and feed that back into the main, you're off in a branch, and then you come back into the main system. But
definitely.
Yeah. How many prototypes did you do?
I don't know. I have a bin under my desk of all the 3D prints and some machine parts, and each iteration of the tooling of tooled parts as well. And you go through a lot of them. And it was to the point of taking some of these parts to customers and literally dry fitting them on a truck, and making sure the assumptions around where it's going to live and what it's attached to, what it can or can't be attached to, is reasonable.
You have a number of CAD files, I imagine. You have a whole library?
Yeah, it's a
lot of code.
Well, yeah, unfortunately not as organized as I sometimes would hope it would be, but definitely. And with that comes a lot of the, how we narrow the focus, or our iteration is kind of about narrowing the vision of what the product is. When we started this thing, it's, we need as much compute as we can that works in as many environments as we can. And of course, with the finality of hardware, that encourages you to be fairly conservative with the designs, knowing that you can't, change the enclosure material over the air as much as I wish it sometimes. And instead, each iteration is just, okay, how much closer can I get to the actual use case, to the, the edge of the performance that we need or that the customer needs, rather than necessarily what's advertised on a spec sheet always, or what's, seen in comparable products. You're trying to get as close as you can to the actual use case, and going to the customer sites and, getting under the dash and seeing the massive, with some of these systems, it can be a real rat's nest of wiring under the dash that you're ripping out and replacing with, this one box. And it teaches you a lot, I think, about how, for one, just the empathy with the installer of, you're sitting there under the truck in Arizona on some gravel parking lot, bleeding from all the zip ties that are stuff under the dash too, and getting a sense that it's not just this idea of it being easy to install it's not a fiction. It's every single one of the things you can simplify and make easier to install, whether that's one trigger wire or one connector that's easier to install. It really does make a difference, even if those people aren't necessarily the ones signing the check for the device at the end of the day.
And so I'm curious, like, what that kind of looked like for you as you iterate. Like, what kind of things did you end up changing? Like in the enclosures to make that possible.
Yeah. So I actually have one machine from Billet at my desk that was the, probably most conservative iteration of this, where we weren't totally sure what
It was a block of aluminum, and then you took a CNC mill to this thing.
Yeah, just a big chunk of metal. And it ran
for thermals, right?
Yeah, it ran pretty cool. It did run pretty cool, and I was not worried about its survival in the field. But of course, it was overkill for this need. And, a lot of those load cases that we were worried about, I think, in the beginning, turn out not to be reality. You're not blasting all of these IR LEDs at the hottest point of the day, for instance. You're not necessarily running all of the AI features that are assisting the driver when you're sitting in the parking lot. So there's a few pieces of that become more clear as you do more of the installs and get a sense for what the actual use case is.
I think about it as like also understanding the risk, right? With these designs, there's always you want to burn down kind of the risks that you're taking, that something might not work or could fail, or it could be a risk to the schedule, And so I think about the hardware development process as you start out with known risks. You're ambitious. You want to have aggressive goals, and you have teams driving on these concurrent tracks together towards these goals, where we have these kind of dress rehearsals or builds, right? And each way you're burning down risk by studying, say, a communications bus or a water seal, or do we need that feature or not? We're going to go test it in the field and see if it really helps. Is it worth it? Because with more features, you add complexity. More complexity adds risk, and then sometimes you discover something later that in phase 2 or so that there's a new risk. Like, oh man, we didn't think about this. So now let's go back and with this knowledge, we go back and iterate again, getting some of that feedback. Those are the tough ones, right? Where we make late state changes sometimes, but we think it's important enough. And that's the one that can be unsettling for folks, because it's like, hey, this wasn't the specification when we started this project, and now you're changing my goal. Like anybody running project teams, the one thing you use fear is like, oh, now we changed the specification slightly. Right. So yeah, burning down the risk, I think, is so important. So we get to the point where you launch it. You're like, hey, we have studied this thing multiple times. We have done all kinds of reliability testing. We've thrown everything at it. We're confident about its ruggedness, its ability to perform with margin. We know we can make it under a cost profile, and it hits these certain quality and performance goals.
It makes sense. I would be curious to hear about a couple of those examples. Like, as you got later and later in the product development cycle, like, what were the kind of surprising, use cases? Because one thing I think is cool about this, it does open up a lot more possible AI detections and stuff that we could do in the future. It's kind of interesting to think about those, because those are a little bit more like, we could potentially work and develop additional features after the hardware is all finished. How do you kind of vet some of those out, or tease through those use cases to figure out is the hardware platform going to work for those?
Yeah, I think even on the hardware side, we lean in quite significantly with firmware and the back end team to understand what flexibility we have to add more things down the road, right? And so, how much are we taxing, say, its compute power? Where are we seeing models trend? What are we likely to be running in the future? And then you can run that even on a simulator. You can run it on the device and understand resource, how much it's consuming. Study how much memory it needs, how much of the MPU is being used, how much is the CPU being used, how hot is it getting if it gets down to the physical thing, and how much margin do we have, right? And if we come to a more of a product design aspect, there's, you're studying temperature all the while. And so I think one of the things you did early on was to simulate in simulation max performance of all the components on a chip to simulate a realistic situation to see then how hot would it get, and then can your system cool that?
Exactly. Yeah, and it can come down to some of the assumptions that you make early in the project that you sort of earmark as this is, it's definitely an assumption, and when will we be able to, validate that assumption? Not always clear. But I think there are a handful of things that we're, like Ben was saying, you can burn down that risk with every available tool you have. It's
and decoupling, right?
Yeah, it's
right.
simulate every
max software simulation, even though we don't have the final code.
Right.
We'll just say this is the max of the compute that this thing can do, and then we do our thermal testing based on that.
Mm-hmm. And you can get a sense of, okay, at the very beginning, this is how much we're going to use. Once we've actually scoped out what it's going to take, here's how much we're realistically going to use. And then leaving ourselves enough margin that for the, unknown use cases that are yet to be built, that we can actually support those.
Yeah, I think another other example would be, having the ability to expand the memory or storage on the device. Then we can, offer that ability for those who want to have much longer on-device storage, even though we're, sending our data to the cloud, building that in. And I think that is being used by some customers today.
Mm-hmm. And I think another piece is that there are a lot of cameras out there in the world on vehicles, and we, of course, tried to design for as many of them as we possibly can from the get-go. And I think you discover that some of them have heaters on them. Some of them, will blast way more IR illumination than we do, or than that we would have anticipated at the beginning. And knowing that you need to stay agile through the process of discovery of, hey, we have a fleet of however many vehicles that have this one camera that really burns a lot of power.
I think there was a bomb change based on that, right?
There was, yeah. Make sure that we can power up those cameras, and sometimes, you can fix it in firmware. You can, pulse things on and not need to actually change hardware. But finding some of those things did take until the 11th hour in some cases.
Interesting. And did that come out of like a specific customer deployment, or how did that end up like, and was it a specific type of vehicle that you like kind of came across once you actually started getting them out? Or?
Yeah, there's sort of these prototypical, vertical specific suppliers typically for a lot of these cameras. And as we were working through school buses, you find there's some leaders in that, sort of incumbents that were there to disrupt, that then they are not quite as worried about power consumption as, say, somebody that has a passenger car. And thus, once we started deploying on those vehicles, you start to notice pretty quickly, both from field data and from reports from the customer about how things are going.
I see. Yeah, that makes sense. What are the other applications for? I mean, I can imagine having cameras on school buses, but what is a deployment like that look like? Is it that different from the garbage trucks, or how? Like, what kind of applications are they going after?
Yeah, so there's the inside and the outside of the vehicle, and generally with school buses, it can be both, right? So you have a stop arm that comes out, and as people drive by that, you may want to see whether people are blowing through the stop arm. As kids are getting out of the bus, you want to make sure that, people are driving or acting safely around them as well. And then seeing inside the bus to make sure that, you can put back together if somebody's getting bullied or if the bus driver is acting the way that they're supposed to. So there's definitely a different layer to it, given that you have kids on the bus and you want to see what's going on inside there rather than just the garbage hopper or, in your blind spot, for instance. But
it's interesting. There's some commonality though too. Like, think about what's going on in the hopper.
Mm-hmm.
It's like the internal type camera.
Yeah.
Meanwhile, you see the arm on the exterior of a waste truck. Plus, you have your typical reversing and side cameras. I think it's fascinating, to think about how, I think it's like waste management and concrete trucks are the heaviest two types of vehicles that drive around town. Right? They're going into residential neighborhoods every day, and they're just massive, they're really huge tires, and so then it makes so much sense to have that 360 view, and you're going to need to rely on an in-cabin monitor to see if you're turning right in a tight spot, if you're backing up down an alley. And so that's where I think that it makes a ton of sense. And then once we've seen those, we kind of see all around us these heavy duty vehicles that are, doing deliveries, but all these urban areas where there's lots of vulnerable road users.
Yeah, that makes sense. One thing I'm really interested about, just in general, is that like we're going after these companies that are kind of usually operating at scale, and they're especially from a hardware perspective, it's very different than designing for consumer, where like probably really worried about like what the thing looks like exactly what it looks like, that it'll fit into their environment.
Yeah.
Like these deployments are different. I know you guys like really thought about install time, if that makes sense, in debugging. And I can even imagine on a garbage truck, I'm just like thinking through, it's like, how do you even verify that the camera is working? Like how do you guys think through that?
Yeah, I mean, I'll start this, and Marshall, I think you have plenty to add here because you've done so many of the installs. But we've had these meetings since we have first launched into our beta program with this product to really review what's going on with these different installations and what did we learn, right? And our other like dash cam is pretty simple. Once you've installed a couple, you're good to go. You know how to do this. And this system, since there are cameras that you may be mounting, or you're integrating with some cameras that are already wired into a vehicle, either way, you need to think a little bit more about that. And so I think it's critical to have that installer app that you use, and which is a little bit different. Like, so you might actually need that every single time so that you can check the placement of the camera after one is installed, or is it connected properly? Did I get the right wire in, or am I getting the turn signal now? And so I think it's a way we think a little bit differently, is how can we build our tools to make it so it's very easy to install and systematically burn down those issues that pop up, and maybe not every time, but many times. And then again, solving for all these different types of installs: internal camera only, or external camera only, or only a rear camera, or all those put together. So, and also like retrofit versus where your existing camera is already there, or a full new outfit. So.
And I think there's part of our, the magic of the data flywheel is that you can show up on site, especially for existing customers, and be able to tell, hey, you have your turn signals on the CAN bus. I don't need to budget any time to, go find in the fuse box where the circuit for the turn signal is. I don't need to bring a wiring diagram with me for that, make, model, year. I can figure out, all right, this is, it's already there. So as soon as I plug into the VG, it's just gonna work. So I think that piece is pretty huge. That, and just being able to know through the installer app and through the other interfaces that we have, hey, this camera's working. It's drawing. At least what we are able to see on the back end is how many even amps it's drawing, one particular camera. Or it helps us remotely diagnose a lot of these things more easily when you can tell exactly what's happening on the device in a way that isn't quite so possible when it's a DVR that you're pulling a hard drive out of, every time you need to look at the footage.
Yeah, that makes sense. I'd be curious to hear from you guys. I know, like at Samsara, like we have amazing, and I'll kind of brag on behalf of you guys, like amazing hardware reliability. And it's such a big deal with these customers, like especially if we're thinking about these environments where like, hey, if you're a large school bus provider, you're going to be rolling out thousands of them. If some of them aren't installed properly, or they end up not working after some period of time, it's a really big deal. Yeah. And I know like our RMA or like return rates are like industry leading. What is that process like, and how do you what are you guys doing during as we go through a product launch like this to actually like really nail that down so that those rates are so low?
Yeah, I think going back to something I touched on earlier in terms of the iterative approach on these builds, it's like it's not just get ready to get the parts together and assemble 100 or 1,000 units. It's now we go through that validation from that dress rehearsal, right? And we go and put it through its paces. I mean, we can talk about the physical challenges we put it through in terms of thermal cycling, where you heat it up, you cool it, and you do that like 1,000 times, and then you go out and test it and test all the aspects as it performs still. You can think about shock and vibration. I mean, I think on the mechanical side, there's quite a bit. But there's also, set up a farm of them and run through simulations, feed them video and make sure they can do detections at different temperatures. And so there's also a bunch of industry standards which we want to go and test compliance to, but not only compliance but performance too, and that we can beat those with margin. Make sure that even goes down to, if you think about it on the firmware side, we'll look at, great, are we able to actuate, operate everything as we would expect, and we'll do that 100% inspection in a factory, right? So in a factory, you may test these electrical pathways multiple times, mechanical pathways, water ingress in a factory. But there's also, when we do our special builds in engineering, we go through these extra validation for all these reliability tests. I don't know, Marshall, you have anything to add there?
Yeah, I think the other magic of the time we live in is you can simulate reliability with at least all simulations are wrong, some are useful, but I think that one in particular has come a decently long ways as far as getting an idea. This component in this corner of the board right next to this screw point might have a problem at this frequency. You can get very specific with some of the tools that are available now, even before you start building and testing and shaking and heating and all that kind of stuff, which was certainly valuable in this product.
Yeah, because like automotive situation, you're in high temp, you're in high vibration, you're in shock, or drop testing, because maybe somebody drops it by accident on the way to install. You don't want things to break off, and so all these things we have to kind of just think through based on what we've learned historically, but also what's different about this product, that we may not have solved before. And so that's why we have to keep eyes wide open about, if any little thing, if there's ever one unit that fails on the line, we go and deep dive and figure out what is our corrective action on this. Because I think it comes down to that, studying that long tail, right? It's not, I'm 99% good. It's, well, let's deep dive on the 1% and let's go systematically figure out what we can do. And that's what it takes to get, I think, that type of reliability, is you focus on any one issue and all of those. and you continue to do so even after you launch it. If a customer ever has one fail, we go and we study that. And because now we have the ability to catch those very, very small quantity of failures that could potentially happen in the future. And we can catch them early on in the program. And I call it just the early field failure analysis. And so we run that EFFA program for all products, and that's super critical.
Yeah, it makes sense. I'd be curious to hear from you guys, like what's been customer feedback so far as we've gotten this out in the field.
Yeah, I think we're seeing them light up by the thousands, and that's been pretty exciting to see. I mean, I think honestly, for engineers, like when you get to design something and release something, I think that's one of the greatest things when it brings utility to humans, right? So
Definitely.
I think we've heard a lot about visibility, and what that brings into the cab that was lacking before, the remote accessibility of some of these views. I've seen some videos where we're capturing some from our beta partners and looking at whether the kid on a bicycle who's behind a vehicle that's really large and they're backing up, and it can set off an alert and alert the driver to make sure they can take evasive action there, or just providing that capture real time of an incident, or if there is, God forbid, an accident, that it gives them greater visibility around it. But Marshall, you've seen some of these too.
Yeah, I think with every, again, finality of hardware, there's a little pinch of anxiety that comes with that. It's like you're watching those dashboards very closely to make sure that, like I said, all those assumptions that you made before are roughly the right thing. In this case, it's been primarily good news, thank goodness. But yeah, I think hearing from some customers that, the vehicles we installed on, those drivers won't go out in other vehicles. They only want the ones that have the cameras and the alerts on them. That was, I don't want to say I was surprised by that, but I think that was definitely good feedback to hear. And then you don't want anyone to get in an accident, but the first time a customer called us up and said, hey, we had an accident in this test vehicle, like, can you pull back the footage and, get us paid out by our insurance? Nobody got hurt, and it was, thankfully very minor, but the first time we were able to do that was like, okay, it's pretty plainly clear you could see in the side camera what was happening where you couldn't see it anywhere else. And that was super valuable.
Yeah, that makes sense. I feel like the visibility, both for just understanding exactly what happened, and then we've seen it in the other applications, right? Just with our traditional safety program, like being able to go out, take corrective action, as in like think through, like, do we need more training? Do we need to change a policy internally for how our things operate? Like it makes total sense how adding visibility and then local feedback through the stuff will make such a big difference in terms of safety outcomes.
Also the other thing is really interesting to hear is, because the installation is, can be, fairly significant, but just hearing how the installation times have dropped so significantly as people get more comfortable with this. And there's like, a learning curve, but, in combination with the app and proper documentation and just skill, I think people have really sped this up, and I think that's been a pleasant surprise.
Well, hey, it's great to have you guys both on the podcast talking about the AI Multicam just a little bit. Really appreciate you both coming on.
No, it was fun. We miss Karen, but we'll find him around.
Yeah, exactly.